So, what happens then at the end? The long or the short goodbye? This just shows that there's some critical masses as to whether a star becomes a white dwarf with an associated planetary nebula, which I'm going to show you, or bigger stars explode as supernova and form neutron stars or black holes. So let's look at this case first, just quickly. These are planetary nebulae. Now what's going on here? These are all very exotic shaped objects, aren't they? Well, we mentioned that when the core of a star collapses and becomes a white dwarf, the outer layers it swells up into a red giant. Well, that process continues. All that material keeps moving out, further and further and further away. And then what happens, the core, the white dwarf core, is very hot and emitting in the ultraviolet a lot. And it basically illuminates the shell of gas that is moving away from the core. So the core of the dead star is lighting up its own outer atmosphere that it shed, that is expanding away. And that's what we see in these images. There is a white dwarf core in there, and the material has been expelled and has moved away. And these are very big objects. They're perhaps 3 light years across. So much, much bigger than any solar system that was part of that star. That one's quite clear, isn't it? A big shell of gas and dust. There's a lot of structure in it. And sometimes the material seems to be moving in 2 opposite directions rather than just spherical. This one is quite mysterious, the shape. And yet again, and I think this is my favourite. But again, a lot of structure here. So what's going on as these outer layers move away? And this is one that some of the guys at Jodrell obtained with the Hubble Space Telescope. This is a huge object, and the interesting about this one, if we zoom in on it, we can actually see, can you see that tiny little dot there? You see it?
Oh, yeah.
That's the white dwarf. Remember, that white dwarf is only the size of the Earth, and yet this whole object is several light years across. So that's the sort of thing that happens to stars at the end of their lives. So what's going on? Well, one explanation from this model is that when the star first of all sort of sheds its outer atmosphere, that material moves away at a particular speed. And then later on it might have another episode of shedding more material as it goes through a second phase. Now if the second ejection of material is moving faster than the first one, then the second one will catch up with the first one and they'll interact. Stars are rotating, they have magnetic fields, we think most stars have planetary systems. So all of these things can sort of explain, as this model does, how from a simple ejection of material you start getting very exotic shapes. Now bigger stars, they do the same sorts of things but on a more catastrophic scale. This is Eta Carina. We think probably a double star system in here, and one of the stars is right at that final phase. It's just, you know, a few years away from that final one day of fusing iron and nickel. Now when it gets to that end point and it can't go any further because you can't fuse beyond nickel, then the core is going to collapse completely in on itself to form either a neutron star or a black hole. The rebound from that is what the explosion of the rest of the star is. Now this star has been chucking out its outer atmosphere catastrophically for some time. People have been looking at this for sort of tens of years, and these 2 lobes are huge amounts of material where the star has shed its outer atmosphere in a very catastrophic way. Now this star is going to go supernova any day soon. It might be tonight, tomorrow, next year, in 100 years' time. Well, that's very soon on an astronomical scale. So astronomers are keeping an eye on this all the time because they're going to learn a great deal seeing something go supernova in such detail. Fortunately, it's about 8,000 light years away, so we're all right. You'll be pleased to hear. Another one, you're probably familiar with this constellation? Anyone tell me what it is? Orion, very good. Yeah, we've got Rigel down here, a hot blue star, and Betelgeuse up here, which is a high mass star right at the end of its life, so it's swollen up and become a red giant. And it's going to go supernova any day soon too. It's a bit closer, remind myself, yeah, about 600, 700 light years away, so it's still quite a distance. But when it does go, if you happen to be looking, and maybe people in this room will be privileged to be around when this happens during your lifetimes, it's going to be a very bright object in the sky, possibly for several days. It will probably outshine the moon, it'll cast shadows, so that would be a fantastic thing to actually see. So, and what do we get left behind? Well, we get things like this, the famous Crab Nebula. This is the debris of a star, from a star exploding, and all the material that gets left behind. And here's another one. Now, the thing I want to leave you with, as I conclude, is that, of course, we've talked about stars throughout their lives, especially high-mass stars, creating all the elements that we're familiar with. Now, at the end of their lives, stars push all that material back into the interstellar medium. We get shells of dust and gas moving away as planetary nebulae, and because they take away all the new carbon and oxygen and nitrogen and silicon and so on and so forth, they take all that with them back into the interstellar medium. And when stars explode, they also push a great deal of material back into the interstellar medium, and the energy of supernova enable heavy elements heavier than iron to be formed and generated as well. So all the elements after helium, all the elements in the periodic table that we learnt about in chemistry, they all get generated by stellar processes, and they get pushed into the interstellar medium, and that interstellar medium becomes the next generation of stars, the next molecular clouds. So all the material that we're made of and our planet's made of has not come from our sun, but us and our sun, all that material has come from a previous generation of stars. Because as the galaxy gets older, the amount of elements in it, all the heavy elements, all the elements heavier than helium, is constantly increasing, because stars are constantly coming and going and donating the material they generate back to the galaxy as a whole. So that's quite an interesting thought, that all these things are linked with ourselves and where we're going. Just a little thing here, just read what that says there. It's really making the point that if the physics of the way stars work was different, then we wouldn't be here, would we? And the wonderful thing that all this leads to, that we, every atom of carbon and oxygen and nitrogen and all the other less common elements, every one of those atoms in your body and in my body, they were all made inside stars. So we are literally made of stardust. And that's, I think, really interesting, encouraging, sobering thought to conclude. Thank you very much.